All right. Hi, everyone. I'm Nicholas Sinovic. I am your TA for probably a few computer science courses here at Loyola University Chicago. And I wanted to make this video to help you get started with installing the necessary software for your courses. And the reason why I want to make this video is because I have had many students come to me who have come from different IDEs or online code editors, or even different operating systems, become confused about how to get access to the necessary tooling for the course. Now, I am making this tutorial to focus primarily on installing and configuring Visual Studio Code for the programming languages course as well as for the machine learning course. Now, with that being said, every course is different. Every tooling is different. All the professors here at Loyola have different requirements for their courses. And so if the course you're using, or the course you're in rather, is not using VS Code, there is information I think that is pertinent to you regarding additional software you may want to install. Okay, so let's get started. We are going to focus first on how to install Visual Studio Code to work with a Linux kernel based environment, right? So if you're on Windows or Mac or Linux, this tutorial is going to apply to you because it is effectively operating system agnostic. Now, what's great is that if you actually are on Linux, you can just go to visualstudiocode.com and download for Linux right here. If you're on a operating system that supports Debian packages, or RPM for Arch and other operating systems. Now, I'm not going to be running through the install process because I think that's just a waste of everyone's time. You can click through it. These are very simple. If you know how to install software, you know how to install software. If you were to go here for macOS or Windows, it will show up the respective things you need. Now, I do want to prioritize Windows first because Windows, unlike Mac and unlike Linux, actually, whose Windows kernel is not Linux, right? It is different. However, Microsoft has released this system called Windows Subsystem for Linux. Essentially, what it allows you to do is run and I'm definitely 100% oversimplifying here, a simplified virtual machine within Windows that enables you to run Linux commands that operate on Windows files. All right. So for those who are familiar with MinGW, this is different. MinGW recompiles tools for Linux to work on Windows. WSL is effectively a virtual machine that has exposure to your Windows environment. What's great is that Visual Studio Code actually has first-class support for WSL. So if you have WSL, you could still install Visual Studio Code via the Windows installer, and then VS Code can access your WSL instance, right? I'm not going to go into detail on how to install WSL, but I will leave links for everything we talk about here in the description below. Once you have WSL installed, if you're on Windows or you're on Mac or Linux, I strongly recommend you to install brew.sh, or just known as Homebrew. This is a really nice package manager for Mac OS and Linux that enables you to go out and download the latest versions of packages that might not be released on your package manager. What does this mean? If, for example, you try to install the latest version of Python using the Ubuntu package manager, it is not up to date, right? Whereas if I go here and I search for Python, Python 3, here's the documentation for this. If I actually go and find, there used to be a formula section. I'm sorry. Where am I? What does Homebrew do? Here we go. Now if I search for Python, if I can type it, and there we are. So we could see that we get Python at 3.13. We could also, if we modify this up here, we can do this to 3.12, 3.6, well, 3.6 actually doesn't exist. Oh, used to. 3.8, disabled. Point is that you can really specify the packages that you want to install using Homebrew. I personally think Homebrew is a very efficient way to install and manage your user environment on Mac OS and Linux and WSL. You are welcome to not do that. I just think it is a good option. It is my personal recommendation to install Python using Homebrew, right? Particularly Python at 3.13 or whichever version your course needs. Another tool that you'll need is Git, right? A version control system. I'm not going to go into details about Git because I can rave and rant about Git for hours and hours and hours. I'm a huge fan of it. It is not perfect, but it is very good. Yeah, so install it. You will need it if you want to work with GitHub as well. Okay. One other thing you'll need, so if you are going to be working with Java or any kind of Java or Java virtual machine programming languages or tools, I recommend installing SDKman. This is a whole suite that is very similar to Homebrew, except it's exclusively focused on the Java ecosystem. So if we drill in a little bit further, we could see here are all of the JDK distributions that they support. Each one of these actually has multiple versions within them. So if you need to install, let's say, a Java 8, or a Java 21, or a Java 17, or a Java 24, or even the latest, typically one of these is going to support it. Okay. So not only are JDK supported, but SDKs, or software development kits, are also provided by SDKman, who have guessed it's in the name. There is a lot here. Obviously, you don't need to download everything. I'm not going to recommend downloading everything. I certainly don't download everything. But if you're in the programming languages course, you can install SBT, Scala, Scala CLI, which is just a command line tool, basically to open up like a, what do they call them? Like an interpreter environment where you can just type in code and then, it gives you an output right away. And then Visual VM as well, which is a great utility. All right. I can actually close out of this. I was going to lecture about something here, but it's not necessary. Okay. So by this point, you should have a few things. One, you should have VS Code installed. I'm just going to open up my VS Code. There we go. All right. So you should have VS Code installed. All right. Looks something like this. You will need to install a few extensions, right? And I have quite a bit here because I've done a little bit of work customizing my VS Code over the years. So I'm not saying you need to install all of these. If you want to pause and look at what I have here, go for it. Some of these are good, some of them are bad. Some of them are just fun to have. But the ones that I do recommend is one, if you're on Windows, to install the WSL extension, right? Again, links for all of these in the description. But this is going to enable you to more efficiently leverage WSL within your Visual Studio Code application. What I mean by this, so I guess I am going to lecture about this. Maybe I should have kept that tab open, right? So why don't we diagram this out right now? Yep, great. So let's imagine we have two different environments here. I'm just going to draw this. And can I zoom in a little? Yeah, because the font size is a little tiny. So we have Windows in one, and we have WSL, or Windows Subsystem for Linux, WSL, right? Now, WSL operates within Windows, right? It's not separate. It is a child of the Windows environment. So when you try to run an application like VS Code in Windows, you actually execute it in the Windows environment. So by default, VS Code, I should change the line here, only has access to the Windows environment, right? And it is, there's basically a wall, right? You can imagine a wall that prevents VS Code from efficiently communicating to WSL. So the WSL extension, if I draw a little border here, I'm just going to do that. I'm just going to call it EXT. That kind of looks terrible. There we go. Perfect. And hey, you know what? Why don't I make these dashed? The EXT enables you to communicate with WSL. So that's why you're going to need the WSL extension. If you're in the programming languages course, I recommend installing the Scala syntax from the official Scala Lang, extension, as well as Scala metals. If you are doing anything, I recommend installing Python. So why Python? Why not just stop at Scala and all that? So we live in the world of large language models, and large language models actually, their primary programming language of choice is Python. What do I mean by that? Well, there was this preprint that was published, earlier this year over the summer, where in the abstract they make this claim, right? And I'll post the rest of the paper so you can read it. But they say that LLMs also exhibit a significant preference towards Python as their default language. For high-performance project initialization tasks where Python is not the optimal language, it remains the dominant choice in 58% of cases, and Rust is not used a single time. Now, look, I don't know why Rust was brought up here, but the main takeaway here is that even in programming language-specific tasks, Python is still optimal, right? So why do we care? Because if you can just accept that the LLM is going to generate good Python code, which I think you should if you read this paper, then what you can do is you can actually take that code, import it into a file in your project, right? Or just into a .py file in VS Code, and then modify it so that you end up with the correct comments, semantics, or otherwise, necessary homework or business goals that you can then provide back to ChatGPT or Copilot or Anthropic or Grok or whatever LLM you're using to have it convert from Python or translate from Python to whatever language you need, right? So it's just a little tip. It's something that I personally do. But anyways, I am going to end it there. I have talked long enough. Of course, I'm going to post links for everything down below. Thank you for listening. I will talk to you all later.